Have you ever wondered why Saturn has such large rings compared to other planets in our solar system? Where did they come from? And how old are the rings? Why does Saturn have a tilt? All this and more on this episode of Science Now, my new channel where we dive into topics on the latest science and space news. A researcher posted in an article of Science back on September 15th that a hypothetical missing moon dubbed chrysalis can mean a transitional state, quoted from the Oxford Dictionary, or it could mean the hard shell where a butterfly is formed. Jack Wisdom, a planetary scientist at MIT, said a chrysalis is a cocoon for a butterfly. The satellite chrysalis was dormant for 4.5 billion years, presumably, then suddenly the rings of Saturn emerged from it. Side note, cocoons are actually only for moths and chrysalises are for butterflies. But anywho, the theoretical missing moon could tie up a few loose ends. The moon could have migrated too close to the planet. The ensuing orbital chaos might have then led to the moon's demise, causing it to be destroyed into dust, ice, and debris that formed the iconic rings we all love now. We like it because it's a scenario that explains 2 or 3 different things that were previously not thought of to be related, said study co-writer Jack Wisdom, yes, that's his real name, a planetary scientist at MIT. The rings are related to the tilt. Who would have ever guessed that? Apparently he did after this study. Saturn's rings are surprisingly young in space terms of 150 million years, which means if dinosaurs had telescopes, they may have seen a totally different Saturn than we do now. So why does Saturn have a 27-degree tilt? I mean, it might not seem like a lot to us Earthlings living on a planet with the average tilt of 21.2 to 24.5 degrees, or compared to Uranus' 98-degree tilt, but nevertheless, it was still a mystery that no one knew of. After some careful calculations, this additional lost moon could partly be to blame for its eccentricity. Due to interactions between Titan, theoretical chrysalis, and Neptune could have helped Saturn tip to 36 degrees, causing immense disturbances to its moon and leading to shedding of the moon chrysalis's outer layer. The subsequent destruction of chrysalis could have been the reduced tidal forces and allow Saturn's tilt angle to relax to 27 degrees. It has been long theorized Neptune plays a huge role in the tilt and angle of Saturn's rings. Because of a coincidence in timing between the way the two planets move, Saturn's axis wobbles like a top, and Neptune's entire orbit around our Sun wobbles like a hula hoop. Those two periods both wobble or precess around the same time, referred to as resonance. Scientists theorize that Titan and chrysalis help the planetary precession line up. But proving it wasn't Saturn's internal structure was hard, because it was unknown until Wisdom and his colleagues used precision measurements of Saturn's gravitational field from the Cassini probe, which plunged into Saturn 13 years after orbiting the gas giant, to determine just that, its internal structure. The team specifically worked out Saturn's momentum of inertia, or how much force it would take to tip the planet over to the 27-degree tilt it's at now. They found that momentum of inertia was close to the resonance frequency of Neptune's pull. Close enough not to be a coincidence, but not close enough to be the only reason. Hence why they theorized a missing ring-forming moon. They realized another smallish moon could help Titan bring Saturn and Neptune into resonance from its own gravitational pull. Titan would slowly drift away from Saturn due to chrysalis and Neptune's pull until it synced up with chrysalis. The enhanced gravity doomed poor chrysalis into a chaotic dance around Saturn, finally causing the small moon to wander too close to its host planet, destroying it in the process. Computer models proved the scenario to be possible, but only 17 out of 390 times, or about 0.1% of the time it worked how models predicted. Yet again, such stunning, beautiful rings are extremely rare as well. Well, that's it for this episode of Science Now. If you have any more questions, please leave them in the comments below. Please like, subscribe, and share with someone who loves to learn about space and science. And if you are subscribed and have the bell icon on, you're awesome, and I'll see you in the next episode. That's it for now, and goodbye.